All right, so we're finally at the point where we can talk about heat. So up to this point, we've been talking about energy and temperature. So let's see what the difference is between heat and temperature. So temperature is based on what? Well, we talked about in a previous video that temperature is based on the average kinetic energy of the molecules. So it's the average amount of kinetic energy, the moving of the molecules in the object. So basically what we're doing is measuring the hotness or the coldness of the object. And so that's really what temperature is doing for us. Heat is different. Heat is based on the total internal energy of the molecules. So temperature is based on the average kinetic energy. Heat is based on the total internal energy of the molecules. So the total energy of all of the molecules in that material. And so if you double the amount of the material at the same temperature, it doubles the amount of heat. I know it sounds weird that they're two different things, but again, temperature, average kinetic energy, heat is the total internal energy of the molecules. Okay? So, for example, if we've got these two containers, we can measure the temperature. So we've got them both at 90 degrees. So 90 degrees Celsius is the average kinetic energy. The heat, though, is the total energy that's in these containers. And so here we've got 250 milliliters of water at the 90 degrees. And over here we've got 1 liter, 1,000 milliliters at, 90 degrees Celsius. The thing is, you probably can guess, this one is not just because it says it here, it needs 4 times the ice to cool, but even if we didn't put ice in it, this container, the liter, is going to take a lot longer to cool down than this one over here. And this is because of that heat, because of the total internal energy. There's a lot more energy that has to be given up or transferred from this container than this container, because there's 4 times as much energy contained here as there is here. Right? So again, heat is a measure of the internal energy that has been absorbed or transferred from one body to another. So temperature, average kinetic energy. Heat is the total internal energy that's been absorbed or transferred from one body to another. And this can happen by 2 processes that you already know. It's kind of nice. There are some terms that you don't have to really learn. So heating, yeah, I know. Heating is the first process. So heating is going to do what to the internal energy of an object? Increase or decrease? Think about it for a second. Yeah, it's going to increase it, because if you're raising the temperature, you raise the temperature by adding energy, right? You use electricity, like on your stove or in your microwave, or you put it over fire. Either way, any way you're doing it, you're going to be adding energy to it when you heat it, which means you're going to increase the internal energy of that material. So you might be able to guess the other process. So heating increases the internal energy. The other process is cooling. So cooling is going to decrease the internal energy. So it's the process that's going to remove energy from a material. Okay? So let's take a look at some more specifics on the heating. So we can do heating and cooling, but how does it happen? So one way you can do this is by creating a temperature difference. So heat will always transfer from higher temperatures to lower temperatures. So the energy from that object is going to transfer naturally from high temperatures to low temperatures. And if you think about it, you're already familiar with this. If your hands are cold, what will you do with them? Right? If you have a mug of hot coffee or tea or chocolate or whatever it is your favorite beverage is that's warm, you put your hands on that hot mug, and over time, your hands get warmer. And that's because the energy, the heat from that mug is going to move from the mug to your hands. If you don't have a mug handy, you probably stick your hands in your pockets or under your arms. Those are areas that are warmer on your body, and the heat transfers from those areas to your hands, increasing the internal energy of your hands, heating them up. Okay, so that's a pretty common way for us to actually heat something. It's also a way to cool something, right? If you want to cool something down, you can put something that is warmer next to it, and it will cool it down by drawing that heat away. All right. The other one is energy form conversion. And this one is one that we do a lot too. We just don't think about it. So this is transferring energy by working. So moving energy by doing work. And so what are some examples of this? Well, one is probably you're using right now, you're just not thinking about it. And that is if you're on a laptop. So your laptop uses a battery that is going to create electrical energy. And that electrical energy is creating light energy on your screen so that we can see, so you can see it. So that is energy form conversion. When that happens, every time we do energy form conversion, going from electrical to light energy or electrical to mechanical energy, so using electricity to run a machine like a refrigerator, you lose some of the energy as heat. And so this is why things like your laptop get warm, because they're actually taking and losing some of that heat as they do the work. This is also why the outside, the underneath, and the back of refrigerators get warm, because they're losing heat as they do their job, taking that electricity and turning it into the work that the refrigerator is doing by reducing the temperature inside. In fact, pretty much every machine that we have, you're going to see this with. Think about your car, right? You're going to run your car, you get out, you put your hand on the hood, it's going to be hot. That's because a good amount of the fuel that you've been burning has been transferred to heat because our vehicles aren't very efficient. So some of that went from fuel, one form of energy, to mechanical energy, running the wheels on your car, but a large amount of it went to heat as that happened. All right, so how do we measure heat? Well, heat is measured in metric units. Again, we're a science class, so but you're familiar with this metric unit. You've seen it before because the metric unit for heat is the calorie. Now, you'll see here, this is calorie with a little c. So what this is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. So very small amount of water by just 1 degree Celsius. Now, the calorie that you're familiar with is the kilocalorie, or calorie with a big C. This is the calorie that you see when you're looking at calories on, food containers and so forth, because we need to measure it in thousands instead of singles. So this is 1,000 of these calories. because a kilocalorie is the energy needed to raise the temperature of a kilogram of water by 1 degree. And so our food energy is measured in calories, big K, kilocalories, in order to be able to not have to put lots and lots of zeros after things. So next time you see a food package, take a look, because these are the ones that it's going to be marked with. Either kcal, big calorie with a big C, or big CAL. So how does this relate to energy, like what we've been seeing? Well, 1 calorie is equal to 4 joules. So when you were looking at things like gravitational potential energy and kinetic energy, the joule is the measure of energy. So 1 calorie is equal roughly to 4 joules. So there's a decent amount of energy in a calorie. All right, that wraps up this section on heat. The next section that you'll be studying is how heat is transferred.